Have you ever considered hiring a personal coach? I'm currently training to become a certified professional coach, and I will begin accepting a limited number of clients in November of 2019. The key tool of coaching is asking empowering questions to help clients live more fulfilling lives. If you think you might benefit from this approach, you can learn more by emailing me at brainsciencepodcast@gmail.com or visit brainsciencepodcast.com/coaching. Welcome to Brain Science, the podcast where we explore how recent discoveries in neuroscience are unraveling the mystery of how our brain makes us human. This is episode 161, and I'm your host, Dr. Ginger Campbell. Today's episode is the second part of our four-part series about the neuroscience of consciousness. The episodes are intended to build on one another, but it's okay to listen to them in any order. If you haven't listened to episode 160, I encourage you to go back after you finish today's episode. Today's episode is an interview with Joseph Ledoux about his new book, The Deep History of Ourselves, the 4 billion year story of how we got conscious brains. You'll find complete show notes and episode transcripts at our website at brainsciencepodcast.com. You can send me feedback at brainsciencepodcast@gmail.com, voice feedback via speakpipe.com/Doc Artemis. And of course, you can post to the Brain Science Podcast Facebook fan page. I usually like to jump right into the interview, but today I need to make a few comments about the feedback I got on last month's episode, which was, of course, part 1 of this series. One listener was concerned that I did not credit Dr. Bernard Baers for the original formulation of the global workspace theory. My apologies to Dr. Baers, and I want to note that Stanislav Dehaene gives Baers ample credit in his book. There seems to be a lot of excitement about this series, and I have to say that I've found it very rewarding to explore consciousness in more detail. Several listeners have asked me to be more explicit about my own opinions. Beyond the obvious implications from which books and scientists I've chosen, I'm going to try to save my personal reflections to the end of the series. I encourage you to listen to each guest with an open mind. The odds are that we will all be in a different place by the end of this series. Joseph Ledoux, it's great to have you on Brain Science after all this time.
Well, thank you for having me.
I usually like to ask guests to start out by telling listeners just a little bit about themselves.
I'm a scientist, a neuroscientist, and I've been doing this for, more than 4 decades. I didn't come into this as a scientist, though. I had 2 degrees in business administration from Louisiana State University. I grew up in Louisiana, and I wasn't very interested in it, but it allowed me to learn a bit about psychology. And through psychology, I ended up working in a lab of a fellow studying rat brains and memory, and sort of fell in love with it. I had no idea you could do that. So I went on to graduate school and studied consciousness in split brain patients. And that was easy because you didn't need to know too much about the brain. It wasn't that much known at the time anyway, and this is the mid-'70s. But by coming into it in a kind of simplistic way, left, right, front, back, it was easy to get into it. And from there, I decided I wanted to dive much deeper into neuroscience and started doing research on rodents to pursue some questions that had come up in the split brain work. And that's really what I've been doing ever since. But the split brain work on consciousness has been, I won't say the elephant in the closet, because sometimes it's not in the closet, but it's been something that's followed me around like a shadow my whole career. Occasionally, I've written about it in my books, though, although I've never researched it since the time I left that work in graduate school.
Great. And what do you do when you're not doing neuroscience?
I'm a part-time musician. I have a couple of groups that I play with occasionally, and mostly I play in an acoustic duo now, which is just two people with acoustic guitars. That's a lot easier than getting the whole amygdaloids band together and dragging equipment around New York City or wherever else we're playing. So we tend to, the duo does the amygdaloid songs just in a kind of unplugged way.
Right. I think I've got some amygdaloid songs. Maybe I got them as a bonus to Anxious or...
Oh, okay. Yeah. So last book was called Anxious, and there was a download code in the preface of that book that allowed you to download the album Anxious that was based on themes that came out of the book Anxious.
Yeah, and I did listen to that. I'm not a big listener to music because I usually am listening either to audiobooks or podcasts, but I did download it. I know you've written quite a few books, but can you give us an overview of your new book and tell us maybe a little bit about how it's different from what you've done before?
As we sort of got into a little bit earlier, I've spent most of my scientific career studying rodents. And what I've worked on all that time was how the brain detects and responds to danger. In the new book, what I do is I start asking myself, the reason I got into the book was I started asking myself, how far back in evolution does the ability to detect and respond to danger go? Obviously, other animals do that, including other vertebrates, even invertebrates. A fly or a bee has to be able to detect danger. But it's a much older process than that. In fact, if you look at protozoa like amoeba, paramecia, they swim around in their environment. If they encounter something harmful, some toxic level of acid or something, they swim away from it. And even bacteria do this. So what I ended up concluding is that we don't get to the beginning of where danger had to be detected until we get to the beginning of life. The first organisms that ever lived had to be able to detect and respond to danger in order to get through the day. And it's not only detecting and responding to danger. Bacteria cells have to do several things that are very common to us. One is they detect and respond to danger. They have to incorporate nutrients and balance fluids and ions, thermoregulate, and reproduce for their species to survive. Now, those things are things that you would think of in terms of animal behavior, but they're also very characteristic of single-cell microbes. So the question is then, does our behavior, when we do those things, have anything to do with all of that stuff that happened way back there 4 billion years ago? And I think it does. I mean, obviously we do things very differently than bacteria, but the task of staying alive for us and our cells, I mean, basically we're just a bunch of cells, that task is not that different from what other organisms that exist that are very different from us have to do to get through the day. The point is that these things in an organism are not there to make, when we eat or drink or have sex or run away from danger, we have certain subjective experiences. But those subjective experiences are not essential to those behaviors. Those behaviors exist 4 billion years ago, and the point of them is not to give you feelings, but to keep you alive. And that, I think, is the fundamental point of the book. How do we get from bacteria to humans, understanding the role of these kinds of behaviors at various levels of evolutionary change over the long history of this process that somehow gave rise to what we do. Now, the important thing about bacteria and protozoa is that they don't have nervous systems. So behavior, and even, in fact, learning and memory, does not require a nervous system. These are things that are simply part of the cell's ability to survive and get through the day. So even when we think of our learning and memory, it's not about having experiences, it's about getting us through the day. Now, obviously, we do care about our experiences, and those are very important to us, and we definitely want to understand those. And that's why the book builds up to the question of where our experiences come from.
So one of the points that you've alluded to here already that I know is a very key point in the book is the relationship between behavior and consciousness. Would you like to address that really explicitly right up front?
Obviously it's a complicated question, and I don't think we have any hard answers to how consciousness works, although there are lots of, I think, really exciting theories around these days. But the question is, we see behavior in other organisms, other people, and we attribute states underlying those behaviors to those organisms and people. Now, in the case of other people, we're on pretty safe ground when we see someone doing something, having some sense of what's going on in their minds when they do it, because they have brains that are more or less like ours. Every human has a human brain. Every dog has a dog brain. Every rat has a rat brain. Every bee has a bee brain. But those brains are very different. And so it would make sense that it's not necessarily exactly the same thing that's going on in all of those organisms when they have a common behavior. For example, when detecting and responding to danger, a bee, if it has an experience, is probably not having an experience quite like what we have. So the issue then is, where do our experiences come from? And can we rely on our ability to observe behavior to tell us about what's going on inside another person or another animal's brain? And I think it's a very complicated situation. So let's just take humans, for example. When we detect and respond to danger, we almost always feel fear. And so we assume that fear has something to do with the reason that we are responding the way we do when we're in danger. These things are so entwined in the brain that they seem inextricable, that fear is the reason that we run from the bear, as William James said. That may not be right, though. So why do I say this? Well, it all has to do with research that I've done over the past, 40 years or so on how the brain detects and responds to danger, and this part of the brain called the amygdala that I've worked on for all these years. So the amygdala is buried deep in the temporal lobe of the brain. It's sort of roughly, if you think of shooting an arrow into your eye and another into your ear, where those two arrows sort of meet in the brain would be kind of where the amygdala is. It's more or less behind the ear and behind the eye. And then, of course, there's one on each side of the brain. We say the amygdala, but there's actually two. And that's just a kind of sloppy scientific logism that we all use, but every part of the brain has two sides. I was studying the amygdala all these years, and the reason I started studying the amygdala was because of my PhD research on consciousness. In studying split brain patients, what we found was that we could induce one side of the brain, and in split brain patients, the two sides of the brain have been separated surgically to help control epilepsy. And I know Mike Kasanaga, my PhD advisor, has been on your show, so your listeners may remember that discussion you've had with him. But in these patients, the two sides have somewhat independent. So when you put a stimulus into the left hemisphere by presenting it to the right visual field, the left hemisphere can talk about it, because in most people, language is on the left side of the brain. So you put a picture of an apple in the right visual field, and the left hemisphere says, oh, that's an apple. If you put the same picture into the left visual field and going to the right hemisphere, you say, what did you see? The patient says nothing. That's his left hemisphere talking. The left hemisphere didn't see anything. But the right hemisphere did see something, because the left hand connected to the right hemisphere can reach in a bag and palpate the objects there and pull out an apple, as opposed to whatever else is in the bag. So the right hemisphere is able to detect that stimulus. Now, we had a patient who had an unusual situation because of early brain damage due to the epilepsy. This patient developed the ability to read in his right hemisphere, which was relatively unusual. So we could put words into the right hemisphere and have him do things like, we'd flash to the left visual field, stand up. So he would stand up and say, why'd you do that? When you do that kind of situation, you're talking to the left hemisphere. He said, oh, I had to stretch. Or if the word was laugh, and he kind of chuckled, ha, ha, ha. I said, why'd you do that? Oh, you guys are so funny. So time after time, the left hemisphere was making up a narrative that would explain his behavior. so that it would be part of who he was. I mean, it's kind of disturbing if we walk around in life all the time and are performing important behaviors and we don't know why we're doing it. In fact, I think that is something we do all the time. And we have this narrative system to explain why we do that. It's part of how we keep our mental self together, how we feel that we have this unity despite of this multiplicity of the brain underlying our conscious experiences. This led us to the idea that this was an important aspect of what consciousness does, is to weave these tales, generate narratives to keep us kind of held together mentally. And we proposed that one of the systems that might be generating kind of non-conscious states or non-conscious behaviors might be emotional systems. So that you might have a system that detects danger and causes you to respond, and then you consciously are aware that that's happening, and you generate a narrative to explain why you've done that. And so I decided to pursue this, and at the time there was no good techniques to pursue how the brain works in the human at the time, in the late 1970s. fMRI, for example, hadn't come along. I know you talked to Russ Poldrack about fMRI, and I know you have your own opinions about that. But, it's been a very useful technique for mapping out certain aspects of the brain. That technique was not available, so I turned to studies of animals, to rodents, to try and understand in a detailed way what was going on when an animal detects and responds to danger. And that's what led me to the amygdala. I didn't necessarily go looking for the amygdala in this research, but I let the stimulus take me into the brain. In this case, we used an auditory stimulus, a tone. The tone went into the brain and went through the brain and controlled a response. Because the tone had been paired with a mild electric shock one time, the tone would then elicit freezing behavior in the rat, and also increases in blood pressure and heart rate. So these responses could be reliably triggered by a tone that had been associated with something significant in the animal's life. Now, at the time, the amygdala had already been known to be involved in these kinds of aversive behaviors, but it wasn't really understood how it was connected up with the rest of the brain very well. And I think that's what we were able to do in the early studies that I did, first at Cornell Medical School in New York, and then at NYU uptown in New York, downtown. And the work we did was able to show that how the tone went into the auditory system, flowed through the circuits in the brain, ended up in the amygdala, and then went out of the amygdala to control behavioral and physiological responses. So it was a wiring problem that we were able to solve because there were new techniques at the time that allowed you to do that. For example, techniques such as tracing pathways. You could put a chemical in one part of the brain, and the neurons there would take it up and transport it all the way to the ends of the neuron, to the end of the axon where the terminal is, connecting up with other neurons. So we were able to trace these pathways through the circuitry and identify exactly what the pathways were in terms of getting the tone out to the body. So because I was interested in how this might be an unconscious process, I didn't interpret the amygdala as being the seat of our conscious fear. We talked about it in terms of fear, but not conscious fear. And what I mean by that is that at the time, starting in the mid-'80s or so, the idea of implicit and explicit memory had come into in the popular language of science. And the idea there was that some of our memories allow us to be conscious of the information, and other memories, though, mainly control our behavior, and we don't really have conscious access to that. And it turned out that the amygdala was not involved in these conscious memories. It was involved more in these implicit or unconscious memories, non-conscious memories about detecting and responding to danger. So what I decided to do was to talk about emotion in these terms that had been used to talk about memory, implicit and explicit. I thought of explicit emotion, conscious emotional experiences, as being products of cortical areas and involving these narratives that we talked about as described in the split brain patients. But the non-conscious memories were coming out of the amygdala and are implicit. So the amygdala doesn't experience fear, it instead produces responses. Now, that idea didn't really catch on, the difference between implicit fear and explicit fear. It was just too complicated. Even scientists didn't really get on board with that. Even though it was sort of implicitly accepted, we all, and myself included, we talked about fear without making the distinction. And that was the problem. That led us into lots of conceptual problems that we're still struggling with in the field. So in the new book, what I tried to do is to take this a step further. I started doing this in Anxious as well.
I want to share a tool with you that will help you to take control of your time by handling repetitive typing tasks. It's called Text Expander, and it's available for both Mac and Windows. With Text Expander's intuitive visual interface, you can create snippets containing words, phrases, and even entire documents. When I got the opportunity to include Text Expander as an advertiser on Brain Science, I was really excited because this is a tool I literally use every day. If you would like to get 20% off your first year of Text Expander, just go to textexpander.com/podcast and be sure to tell them that you heard about it on Brain Science. That's textexpander.com/podcast.
In this new book, I tried to be very explicit about why we should not be talking about the amygdala as a fear center. Fear is a subjective state word. Like love and other kinds of words like this, they refer to the experiences that humans have in social and other kinds of situations. I think it's a problem when we use subjective state terms to describe behavior, words to describe non-subjective control systems in the brain. And the amygdala is a good example of what the problem is. So when you lesion the amygdala in a rat, the rat no longer detects and responds to danger. So a tone that's been paired with shock will no longer elicit freezing. The assumption is that the rat is no longer feeling afraid, and therefore that's why it's not responding. But there have been human cases with amygdala damage that still report the experience of fear. And this is important because it suggests then that the amygdala is not responsible for the feeling of fear, but instead for the behavioral and physiological responses. But these things are so entwined in our brains, every time we're freezing to danger, we're usually afraid. So it seems like they go hand in hand. But in fact, there are lots of examples besides simply the one or two patients that still feel fear despite having a hole in their amygdala from various kinds of pathology. There are other examples. So we can present a stimulus to an intact brain, a person doesn't have any known pathology in their brain, and present that stimulus in such a way that the person doesn't know the stimulus is there. This is called subliminal stimulation, subliminal perception. So you do that by presenting the stimulus very, very briefly, and then following it with something called a mask. So let's say you've got a picture of a snake. You flash that snake to the person at 20 milliseconds, 20 or 30 milliseconds. And as soon as the flash is over, you present what's called visual white noise. That would be just a kind of mass of nonsense information on the screen. And that helps blank out the stimulus. In the old days, the researchers would only use the brief flash, but they found then that maybe there was something leaking through into consciousness, so they started using the mask as well. So when you present a masked picture of a snake to a human, that stimulus will go to their brain, activate the amygdala, and produce the responses like increases in heart rate or sweating. But the person doesn't know the stimulus is there and doesn't report feeling fear. Now, if you have the person in an imaging experiment, let's say an fMRI study, and you record what's going on in the brain when the person is able to report what the stimulus is or is unable to report because it's been masked, what you see is something very interesting. When the stimulus is a threat and it's masked, you get activation of the visual cortex, of the amygdala, and that's it. But when the stimulus is not masked, you get activation of the visual cortex, the amygdala, and the prefrontal cortex as well. So the prefrontal cortex is emerging as an important area for the consolidation of our conscious experiences into what they are. When the stimulus makes it to the prefrontal cortex, we can tell other people about our experiences. But when it's not making it to the prefrontal cortex, those experiences are not even available to us in our own minds. So this is another reason to say that the amygdala is important for the control of responses, but not for the experience of fear. Other reasons, if you look at, for example, people who have problems with fear and anxiety and look at their behavioral responses versus their physiological responses versus their subjective awareness of events, these three things do not correlate. The behavior and physiology go together pretty well, but the subjective experiences don't correlate so well with those other physiological and behavioral responses. And there are many other examples I could give, but all of this adds up to the fact that the brain mechanisms that control our ability to detect and respond to danger are not the same as those that give rise to our conscious subjective experiences. So if we start tracing those mechanisms back, the ability to detect and respond to danger, independent of the issue of fear, what we see is a line that goes back to the first cell that ever lived, that first protobacterial cell 3.8 billion years ago. We can follow that all the way up from bacteria to protozoa, from protozoa to sponge and jellyfish, on into bilateral organisms, bugs and slugs and all of those things, on into vertebrates, on into fish, reptiles, birds, mammals, us. So the ability to detect and respond to danger is as old as life, but fear may be a much more recent addition. Now, in the deep history of ourselves, there are two, you might say, crazy or radical ideas that come out, and one of them is contrary to popular ideas such as the limbic system theory that proposes that with the evolution of mammals, certain circuits, the so-called limbic circuits, evolved to allow mammals to have these conscious emotions. And in later mammals, especially primates and then finally humans, consciousness emerges in the cognitive sense. We have this cognitive brain on top, layered over this limbic brain underneath. Limbic brain is generating our emotions. The cognitive brain is doing language and consciousness and all that. But emotions are conscious in this limbic system theory. Now, what I propose is sort of the opposite, that what came first was cognition, not emotion. And the reason for that is if there are aspects of cognition, if by cognition what we mean is the ability to form internal representations of stimuli and to behave on the basis of those representations to stimuli that are not present. In other words, you use a stored representation of a cue that's been associated with food, with danger, with sex, and those representations can then guide your behavior independent of the presence of the actual stimulus. You can have a mental representation that is guiding behavior. That capacity exists in invertebrates. It's relatively primitive in invertebrates, but it is a cognitive representational ability. You can take that on into vertebrates. Fish have that. Reptiles have that. When you get to mammals, you get a much more complex kind of cognitive representation where it begins to be a more what we would call deliberative. And by that, I mean the ability to form mental models that can be predictive of things that are not existing. It's a much more complicated thing than simply having a kind of static memory of what's there. With mammals, we do get more complicated forms of cognition, but then from that, we assume that because a mammal is behaving the way we behave when we are in a similar situation, that it must be having the same kind of experience. But I think the amygdala example of fear gives us some reason to be cautious about that, because we see that fear, even though fear is totally correlated in many of our encounters with danger, it's not necessarily the case that the amygdala is generating that fear. So we've come to associate the amygdala with fear because of the behavioral responses, which sort of hoodwink us into thinking that the feelings must be there too.
So, just to summarize, the short answer is that you should actually assume that behavior is unconscious unless proven otherwise, rather than concluding that some behavior is conscious just because it looks like something we think we do consciously.
Exactly. There are lots of studies that try to address all of this, but let's talk about it in humans first, because I think it's very enlightening to see what happens in a human when we are trying to prove that something is conscious or non-conscious. So the standard way to do that is we know that we have these conscious experiences. We all have them. We talk to each other about them. That's not enough to make a point in an experiment. In an experiment, you're not asking in general, could this be conscious? You're asking, can the response in this experiment be explained by a conscious state? It's a very specific question scientifically. So in order to show that that response is conscious, you have to rule out that it can't be explained non-consciously, because we know that lots of human behavior is non-conscious. I mean, we have this vast cognitive unconscious that cognitive scientists have been talking about for a long time. This repository of information that allows us to get through the day without having to consciously evaluate everything we do. So I just said, get through the day without having to consciously evaluate everything we do. So, there were subject, objects, verbs in there. I didn't plan those. Those just kind of came out. That's part of what the cognitive unconscious does. It takes care of our grammar. It allows us to anticipate what we're looking at before we actually completely see it. It allows us to complete patterns on the basis of limited information. And sometimes those predictions are wrong, but in general, that's how the brain works, and it works pretty well because that means we don't have to waste our time getting from point A to point Z every time we have an experience. We simply can get to point C or D, and that's enough to solve the problem for us. If that turns out not to be sufficient, then we have to do more processing and we update that. So a lot of human behavior is controlled non-consciously. But to separate what's conscious and non-conscious, you do the experiment. And so, for example, in one of these subliminal experiments that I described earlier, the critics of non-conscious processing are always finding ways, well, maybe something leaked through that stimulus, so now we have to add a mask to the subliminal stimulus. Are there other things we have to do to make sure that nothing leaked through that could account for the behavior as a conscious experience? So the criteria over the years keep getting more and more and more strict as to what can count as non-conscious processing. But it's there, and it is fairly robust in terms of what it does for us. So why can we do that? Well, the reason we can do those things in people is because the gold standard for determining whether you're conscious or not the only standard, but the gold standard is whether you can talk about it. Now, that doesn't mean that language and consciousness are one and the same thing. But in general, you have cognitive access and the ability to talk about things that you're conscious of, but something you aren't conscious of, give a cognitive conscious report of it. So that's a tremendous asset research-wise because it allows us to force a wedge between what is clearly unconscious and what is clearly conscious. That's been very useful in human research. Now let's turn to animal research. The problem there is
we can't ask.
We don't have that wedge. An animal can only respond non-verbally. That doesn't mean it's not conscious, but we don't have a scientific tool for allowing us to say yes or no the way we do in people for the extreme cases. Well, people are very confident of the conscious experiences of their pets. I go home at night, I pet my cat Petey, he purrs. Everything's good with the world. I treat him as if he's conscious, and that's totally appropriate. We don't have to be scientists in every aspect of our lives. We don't have to use science to do everything we do. I think it's it's good for us and good for animals to treat them as if they have these feelings, but it's not a scientific demonstration to just watch its behavior and say that it is. It's just, the scientific question is, can we show that in this case, in an animal experiment or a human experiment, that a non-conscious explanation won't do? Then you can say it's conscious. If a non-conscious explanation will do, then you can't say it's conscious. It's a very complicated thing. And again, I'm not saying that animals have no experiences, but what I am saying is maybe that's not the most important thing scientifically. It's very important for us as people who have pets, as people who have values in a culture, and different cultures deal with animals in different ways. And I am a total respecter of animals. I do research on animals, but we do that following all of the guidelines that our society allows us to use for that. One strategy that I've proposed is that, maybe what's really important is not that we try to force things that are not provable onto animals, because that just leads to more controversy. Marion Dawkins, for example, said tying the problem of animal welfare to the problem of consciousness is bad for animal welfare, because what it does is it ties it up into an unprovable debate. So I would like to shift the conversation to not looking at things we can't measure in animals, but things we can. And there's so much that we share with animals close to us cognitively that we can learn more about, that we can learn so much about the cognitive underpinnings that actually contribute to our conscious experiences. And we can study those in animals, even if we can't relate those to conscious experiences in animals. It takes us into a richer understanding of the brain if we kind of leave consciousness out where we can't actually study it. Now, I think a lot of our concerns and debates go back to Darwin in the 19th century, when he proposed that emotions were mental states that we've inherited from animals. When he talked about emotions, he talked about animal emotions in terms of human experience. Now, a journalist asked him at the time, your research and your ideas have all been based on how physical parts of the body have evolved over time and how those transitions from different organisms lead to new organisms, so that we can think of our bodies as these animal bodies. But when you talk about emotions, you talk about animal emotions as if they're human emotions. And he said, well, it's I think he said, a kind of way to think about it. Or basically, if you read what he's talking about here, it's about getting the public to accept the theory of evolution in a more friendly way than to think of people as having these bestial qualities, to think of animals as having these human qualities, human mental qualities. And I think that set the debate off on a track that's been difficult to get past. There was tremendous anthropomorphism in the late 19th century that led to the radical behaviorist movement in the 20th century, where all of conscious experience was eliminated from research because it had been so abused in the late 19th century in terms of what was allowed, what was called conscious and what was not. So later researchers obviously came along and said, well, we can't completely eliminate mental states from human behavior, much less animal behavior. So the cognitive revolution came along, and what it did was it brought the mind back, but it didn't bring back the mind that the behaviors got rid of. It brought back the mind as an information processing system, a system that takes in information. Some of that ends up being conscious, but most of it does not. So that's where we get the idea of this cognitive unconscious. So there's a tremendous cognitive unconscious that is a middle ground between the choice that the behaviorist debates led to, conscious versus reflex machines, or behavioral machines, conditioned responses versus consciousness. There's this whole intermediate territory called the cognitive unconscious that has robust processes that allow us to control complex behaviors without having to call upon consciousness. And I think that's a much more productive line of research than trying to force questions about animal consciousness into the research program. Now, again, I think it's perfectly natural, and some people have said that anthropomorphism may be an innate human quality, because it was very useful for early humans to interact with animals and it was important for the development of agriculture and farming and so forth. It could be something that we've inherited from early humans because it was useful to them and therefore built into our genome as well. But just because it's innate doesn't mean conceptually it accounts for anything. That's a whole different question.
Well, I have to say that, I was a little resistant to your point of view and I think it took me several readings to really, I think, finally really grasp what you're saying. And the turning point was when I realized, well, it has to do with this whole idea of unconscious cognition. The more we study, the more we realize that stuff that we've assumed that as humans that we do, that we're in conscious control of, right? That are actually being done unconsciously. And that our actual consciousness is a very thin veneer on the whole procedure, right? That kind of flips it over to, oh yeah, so if I'm wrong half the time when I think I'm doing something consciously and you did an experiment and you could prove it was unconscious, which this has been done, then straight extrapolating consciousness to animal behavior is kind of the same sort of error.
Right. And again, it doesn't mean that they aren't conscious. It just means that scientifically, we don't know.
Right. This month, Brain Science has a new sponsor, BetterHelp, an online counseling service that features 3,000 counselors in 50 states. You can schedule sessions via secure video or phone and go at your own pace. These are licensed counselors that specialize in a wide variety of issues. And of course, everything is confidential. If you're not happy with your counselor, you can change free of charge. As I said, online counseling is private and confidential and less time-consuming than traveling to someone's office. You can do it from anywhere in the world. BetterHelp even has financial aid for those who qualify, but please note it's not a crisis line. BetterHelp is offering a 10% discount off your first session if you use the discount code GINGER, GINGER. So get started today by going to betterhelp.com/GINGER. Just fill out a questionnaire to help them assess your needs and get matched to a counselor that you will love. That's betterhelp.com/ginger. I wanted to ask you, you had a couple of chapters in the book where you really explained the reason why a couple of the persistent ideas that we continue to hear about, especially with regards to the limbic system and the idea that parts of our brain sort of evolved in this sort of serial way, especially the triune brain. I have to admit that I read Carl Sagan's The Dragon of Eden when I was a young person, so that one really stuck in my head. Would you mind explaining why those ideas are outdated and we should let go of them? Because they just keep appearing.
Right. I've been on an anti-limbic system kick since, the late 80s. I started writing about that. What got me on that was research that I did sort of part-time when I was in graduate school. I worked with a guy named Harvey Carton, who taught me how to do this new axonal transport pathway tracing stuff in the brain. And he was an evolutionary neurobiologist. So his work was on how brains like bird brains and reptile brains came into being. And one of the things he showed was that in the bird brain, and then others have shown in reptiles as well, there are traces of what we call now neocortex. So the limbic system theory was based on a model by a turn of the 20th century German neuroanatomist called Ludwig Ettinger. Now, Ettinger had this building block theory of brain evolution, where first you have this kind of basic reptilian brain upon which was stacked a mammalian brain, upon which was stacked a newer mammalian brain. So these three levels were adopted by Paul MacLean in the limbic system theory. But in the meantime, and by the meantime I mean since the limbic system theory came along, so like in the 1970s, research began to show that certain aspects of Ettinger's theory were not valid. And in particular, it was this idea that birds and reptiles had no neocortex, which was supposed to be the new part of the mammalian brain. Now, if birds and reptiles have elements of neocortex, that kind of challenges the whole limbic system concept, because the limbic system was supposed to be the home of emotions and not cognition, whereas the neocortex was the home of cognition. But if those things are not so separated as we go back in evolution, in other words, that even reptiles, the ancestors of both birds and mammals, have some primitive neocortex, then the neocortex did not start with mammals. So pieces of information like that have called the Ettinger and thus the limbic system theory into question. And that's just one of a number of points that could be made. But in general, another thing that we could say is that in terms of the limbic system, the idea that it's been hard to identify exactly what the limbic system is. The original criteria was connectivity with the hypothalamus, but now with modern techniques, we know the hypothalamus is connected with every part of the brain, including the spinal cord, all the way to the neocortex. So, it kind of waters down what the limbic system might be. At the same time, the idea that emotions are part of the limbic system, whereas cognition and thoughts are part of the neocortex is no longer valid, because we find that there are certain aspects of emotion that the neocortex is particularly required for. And there are other aspects of cognition that depend on subcortical areas. The whole thing just is based on kind of a house of cards at this point. It was a beautifully written and insightful piece when it came out in 1949 and 1952, and then pursued by MacLean for decades later. It was really a groundbreaking kind of revolutionary concept. But with time, we have to let go of things that don't hold up under scientific scrutiny and move on to other ideas.
Yeah, I kind of now use reference to the limbic system as a quick screen when I get sent a book, because I get sent lots of books. And as soon as the author refers to the limbic system, I stop. I know that's probably not fair.
The field is still talking about the limbic system.
I know, but, if they're not going to then say something that shows that they're up to date on its current status, I get worried.
So I talked about one crazy, radical idea that cognition came first before emotion. But the other idea that maybe even a little wilder than the first is that emotions are not initially a product of natural selection. Now that is going to be controversial and maybe surprise you or whoever else is listening right now to say something like that. But what I think happened was that emotions are these cognitively assembled experiences. I know you've had Lisa Barrett on, and our views are moderately similar on this topic, that emotions are conscious experiences that are constructed by these cognitive processes. We differ a bit on what those processes are and what goes on, but the basic idea is very similar. Now, if that happens to be true, then the possibility exists that the cognitive systems that are unique in the human brain might be responsible for those emotions. So maybe emotions came in with the early humans. And maybe they came in not because they had been selected for, but because they were byproducts, or what Stephen Jay Gould had called acceptations, based on other byproducts. If the cognitive model is correct, and I'll just, for the sake of argument, assume that there's some value to it, then emotions are based on things like mental schema, cognitive schema, which are bodies of memories that are based on things you know about certain categories of experiences. For example, we each have a fear schema, memories of everything you've acquired throughout your life about what fear is, how you deal with fear, what kind of situations does fear come out of, how do people act in those situations, what are your most likely responses in those situations, and on and on. So it's a catalog of information. And when in danger, a stimulus, say a snake, goes into your brain. It pattern completes that body of information, which means it just kind of activates a lot of it and creates a kind of cognitive template upon which to interpret the situation in which you find yourself. And that's what fear is, that cognitive interpretation of the situation in which you're in. If we go back to the work I told you about in split brain patients, it's sort of the same thing. We are faced with brain activity, body responses, and the schema are being activated. And then all of a sudden we have the experience of fear. Fear is not what's causing the body responses. Fear is that pattern completion based on the fact that there is something dangerous there that has activated your schema. You pattern complete everything you know about snakes and danger and all of that, and that becomes the template in which you interpret that situation. The fact that your body is responding because your amygdala has also gotten the snake and triggered your heart to race and your palms to sweat, and you find yourself freezing. So you're observing all of this in your body, monitoring it through cognitive processes like working memory. And that is also contributing to the cognitive state that you're in. But I don't think the body responses and the amygdala activity and all of that is determining what you're experiencing. It's more like a modulation. So it's more like, you go into a restaurant in New York and the music is too loud and someone asks it to be turned down, the sound goes down. It's much less annoying and less aversive, but it's the same experience. I mean, the music is the same. It's just the content is the same, but it's just not as annoying because it's not so loud. And I think that's what all of this non-cortical stuff is doing for our emotions. It's sort of turning up the volume of them. And there are certain systems that are preferentially associated with different kinds of stimuli and so forth. And those same stimuli give rise to our experiences and the responses. So the things are correlated because they're triggered by the same stimulus, but they're triggered in parallel. So I think that that's something we need to think a lot about because it has important implications for medications are developed to help people with problems of fear and anxiety. For example, the typical approach would be to take mice and put them through some sort of challenging, difficult situation in which they are threatened in some way, and to try various compounds, molecules, to see whether any of these drugs are going to affect the behavior. So what you find is that if an animal spends more time in the presence of something theoretically dangerous, then you assume that the animal has less fear, and therefore giving that medication to a person will make the person less fearful or anxious. But all you're seeing in the mouse is that the behavior looks less timid. He seems to be spending more time in the presence of the danger. You don't see the fear itself. And so when you give these medications to people, one common finding is that they don't work very well. So a person, say, with social anxiety, given a medication and is told, well, take this for a few weeks and, you'll be able to go to parties and maybe you'll feel less anxious when you go there. But more likely the outcome is the person finds it easier to go to the party, but is still anxious while there. And so the person is disappointed. Psychiatrist is disappointed. The drug companies are disappointed. And for that reason, the drug companies are getting out of the anti-anxiety business because the drugs aren't working. But the drug is working exactly the way it was designed to work or tested to work in the animal models. The person is less timid. They find it easier to go to the party, but they still get anxious while at the party. Now, suppose the psychiatrist had said, well, this drug is based on animal research. It shows the animals are less timid, so it's going to make you less timid about going to parties. So you're going to be able to go to the party. You're an anxious person. You've been anxious for a long time. You may never not be an anxious person. But if you know that the drug is going to help you get to the party and reduce some of the symptoms, behavioral symptoms and physiological arousal that goes with being at the party, it might allow you to be there a little bit and to kind of adapt to it a little better and maybe begin to slowly develop more of a social life. It's not going to be perfect, but it will be a way of helping you cope with this. That psychiatrist and patient would be not disappointed in the result because, as expected, the drug did what the person expected to do rather than what the drug was sold to do, which is to reduce fear and anxiety. So I think, there are big implications for these views about what's going on in the brain and using the brain to look at how circuits in the brain that control processes that happen simultaneously but separately are doing different things. So it's not simply about finding facts about how fear or danger or other things work in the brain. It has important practical implications. So back to why I think that this might have happened in early humans rather than earlier. To be clear, what I'm talking about is not conscious experience itself, but I'm talking about a particular kind of human conscious experience, one in which you know that the experience is happening to you. Since we don't know what's going on in any other animal's mind in any kind of detail, we can't rule that out. But I'm going to give you some neurological evidence that suggests possibly it's not happening in their minds. So this is called Autonoetic Consciousness. It's a term introduced by the psychologist Endel Tulving to describe the ability of the human brain to represent the self as an entity, as a subjective experience. In other words, there are different views of the self. You have a self that's your body, but Autonoetic consciousness is about yourself as a subject, something that is part of the experience. So when you have an experience of danger, it's you that is in danger. I'm wearing a shirt right now that you can't see, but it says, "No self, no fear." And I think that is true, that emotions have to involve the self. If you aren't aware that you are in danger or in love, then you aren't in danger or in love. You have to have the experience of you being part of it. And without this ability for autonoetic consciousness, you can't have that. The other thing autonoetic consciousness does is it allows you to engage in what's called mental time travel. Maybe it doesn't do that, but mental time travel is a part of autonoetic consciousness. Not sure exactly how to frame the relationship. But in mental time travel, you can visit your past experiences and possible future experiences. You can predict your future states. Now, other animals certainly can use past experience to guide their behavior, but in a very limited way. And they also can use prospective cognition in some cases, birds and mammals, to choose what to do. But they don't have this self that is part of that experience. And, efforts that try to get at these issues in animals face the bottleneck of not having that alternate response to compare it with. So, for example, there have been many, many studies of episodic memory or episodic-like memory in birds and mammals and dolphins and other creatures. But in all cases, you hit the bottleneck because there's always a non-conscious alternative that can account for the behavior. It doesn't require that you assume that you have this mental self-representation.
Since this is a rather long episode, I'm going to break in here to remind you that Brain Science relies on listeners like you for financial support. There are three main options for supporting the show: premium subscriptions, Patreon, and single donations. So you can pick the one that's right for you. Just go to brainsciencepodcast.com/donations to learn more. One brief note about direct donations. A new option is Venmo. And if you use Venmo, my username is Doc Artemis. Thanks again for your support.
Why can we assume that other people have it if we can't assume that other animals have it? Well, every person has the same brain, same kind of brain. As we said earlier, we all have human brains. All rats have rat brains. And the human brain has some unique features, especially in the prefrontal cortex. Not so much unique areas, although there is one unique area in the frontal pole part of the prefrontal cortex. This is the part right behind your forehead at the very tip right above your eyes. The frontal pole has not only a unique area that's not present even in other apes, not even in apes or other primates or other mammals, but only in humans. The frontal lobe in general, prefrontal cortex in general, has cellular and molecular properties that are present only in humans. And it has connectivity that is present only in humans, without connectivity with other areas. So there are things about our prefrontal cortex that are unique to us. And because the prefrontal cortex is emerging as important in these subjective experiences, and especially the frontal pole is emerging as being important in these subjective experiences, it may be the case that what we call emotions, these self-infused, excited events that we talk about, by excited, I mean events that are significant to you psychologically or biologically, when we have these experiences, our self is always involved. And if the frontal pole is responsible for that, and the frontal pole is a unique physical part of the frontal lobe with unique properties, then it may be the case that whatever experience we have involving this self can't possibly be shared in the same way with other animals. Other animals may have their own kinds of experiences. Again, we have to be subtle in how we partition things. We can't simply talk about consciousness and non-conscious, just as we can't talk about, conditioning versus consciousness. We've got that whole non-conscious cognition there that we have to deal with. The same thing with consciousness. It's not one thing. I've identified autonoetic consciousness as something special that may be human unique. But even if other animals don't have that, they could have what's called noetic consciousness, which is the awareness of facts and things about themselves and about the world. But it's a more static thing. It's not something that involves the self and this mental time travel to the past or to the future. For example, working memory and prefrontal cortex in non-human primates is very, very similar to what we have in the human brain. That part of the cortex could be involved and has been implicated in these kind of factual, perceptual events, the presence of, an apple or a picture or whatever. And so other primates certainly could have this. These parts of the prefrontal cortex that other primates have, other mammals don't have. But they might have their own kind of noetic consciousness that doesn't require the same thing, but it would be different from what primates have. They also may have what's called anoetic consciousness, which is a more kind of body state kind of awareness that would be, as Jaak Panksepp talked about anoetic consciousness and core consciousness and so forth. And he talked about it as primitive, almost unconscious state of consciousness. So it would be a very limited kind of thing relative to what primates have in terms of noetic consciousness and what humans have in terms of autonoetic consciousness. Now, I'm not saying these are hard facts. I'm just proposing a partition of psychological states based on what we know about the brain structures and pathways involved in those states to propose what might be possible in other animals, even though we can't actually measure it.
Okay. So in your book, you take this evolutionary perspective, which both Antonio Damasio and Daniel Dennett did in their most recent books, but that you reach markedly different conclusions. I think it's pretty clear how your conclusions are different from Damasio's, but I feel stupid, but I'm not exactly clear on the key way in which you diverge from Dennett, and that's probably more of a reflection on his ideas than yours, but can you tell me what the key way that you think your ideas of this whole picture are different from Daniel Dennett's?
Maybe 90% would be the same in terms of what consciousness is. But his point is he had a book called Consciousness Explained, and a lot of people say that consciousness explained away, So he's kind of trying to get rid of the subjective experience. I'm a fan of subjective experience and want to hang on to it. And that's why, I've adopted this higher order theory of consciousness, which is about how subjective experiences themselves come about. This is an idea that has been around for a while, but the strongest proponent of it in modern times is David Rosenthal at the City College and the Graduate Center here in CUNY in New York. The idea is that in order to be conscious of something, for example, an apple, it's not enough to have it just be represented in your visual cortex. It has to be re-represented. And where Rosenthal and his colleague and my colleague, Hakwon Lau, and also Richard Brown. Haquan, Richard, and I have recently written a paper on all this. But the idea is that the re-representation involves prefrontal cortex. And so in order for that visual cortex information to be a subjectively experienced stimulus, it has to make it to prefrontal cortex. So I think, again, that subjective experience is so important because following the behaviorist period, which lasted for decades in psychology, and then the emergence of biological psychiatry in the 1950s, using drugs to treat everything, subjective experience has been marginalized in the field of psychotherapy. What we've been trying to do, I say we, by that I mean me and people that I've written papers with, such as Richard Brown, Haquan Lau, Danny Pine, the psychiatrist, and Stefan Hoffman, the cognitive behavioral therapist, is to emphasize the importance of allowing subjective experience to be an endpoint in therapy. It's all been dismissed as, well, all you have to do is give the drug and change the amygdala and everything will be hunky-dory. But obviously that's not working out so well. Ultimately, if the person doesn't feel better, the therapy is not going to be a success. If their experience is that I'm not better, it's not going to be a success. So you can't dismiss that. We live in this subjective world that we call our minds, and we can't ignore that in life or in problems in life.
I was really referring to Dennett's book, From Bacteria to Bach and Back, because I think that was the book that you alluded to also. In fact, because of that footnote in your book, I went back and reread From Bacteria to Bach and Back. And that's where I'm sort of stuck with, I guess it's just me. Sometimes I can't really figure out what it is that Dennett's trying to get at besides the point of it's all evolution.
Well, in the mad rush to finish my book, I saw his book at some point in the middle, and also Damasio's book. And I was too far in to actually be able to go in and take what they had said and incorporate. It was just way too deep into the narrative, and we were like moving towards publication. And so I wasn't able to put myself in there, but I should go back now and evaluate exactly what Dennett said, because I don't recall. It was, like I said, I just kind of came across it in the last stages there. Antonio and I have been friends for a long time, and even though we have very different views, we're good friends. And I asked him if he would be willing to look at my book and perhaps give as they call in the business, a blurb for it. And he wrote a very generous, nice blurb saying that, that he found much to agree with in my views, and not everything, but, there's a lot of overlap. I think that's true in many of these theories that, until you get to the final finish line there's a lot of similarity. Like Jaak Panksepp and I are thought of as having these drastically different ideas. But underneath it all, it's really pretty much the same until you get to, some of the conclusions. The data is always the same in all of these things, right? We all get the same data. It's just how we interpret it at the end.
Yeah, and just backing up there for just a minute, I realized we left something out. Could you explicitly just address the whole issue of what the subcortical circuits are in your viewpoint? Because you did that very clearly in the book, and I don't think I brought that out.
We talked about how if we work backwards from ourselves, looking for where the beginning of danger detection occurs, we get to the beginning of life. And so as we start going forward, we see that all organisms have these survival behaviors, whether it's detecting danger, incorporating nutrients, balancing fluids and ions, reproducing, and so forth. And so they all have these survival behaviors. They don't all have nervous systems, so they don't have what I call survival circuits. But every animal with a nervous system has a survival circuit. It's something that controls those kinds of survival behaviors. Now, as we go from simple nervous systems to more complex ones, the neural architecture underlying these survival circuits gets more complex. Now, as we get into the various invertebrates, we see that There are lots of circuitry. I mean, that's basically what their circuitry is about, keeping the animal alive. But invertebrates don't have an amygdala. They have their own nervous systems. All vertebrates have the same kind of nervous system, and the vast majority of vertebrates have a nervous system with an amygdala. So the amygdala didn't come out of the blue. It's an extension of what the invertebrate ancestors of vertebrates had in their nervous system. So there's always a line between the beginning of life and us today that can be traced through all of these various levels by understanding the connection between humans and other animals and non-animal organisms like protozoa and so forth, and within the animals between vertebrates and invertebrates. All vertebrates, all animals have survival circuits. Invertebrates, that is, in the vertebrates, survival circuits involve, for example, the amygdala for defense, the hypothalamus for food incorporation and nutrient processing and so forth, the hypothalamus also for reproduction and fluid balance and so forth. And, it's not one structure that's doing all these things. In each case, the amygdala is involved in some of those things, and the hypothalamus is also involved in defense. But different circuitries passing through these structures contribute to these kinds of activities. So the survival circuit, is a circuit that is keyed to specific kinds of cues that then process those cues and initiate survival responses. It might go through the amygdala, or it might bypass the amygdala and go to the hypothalamus. But, the amygdala is a kind of code word for defense. And it's all of these things are approximations. We have to be careful when we talk about brain areas as if they do something. They don't do anything. They're just important because neurons within brain areas connect with neurons in other brain areas to allow information to be processed in a certain way to control behavior. But when we talk about defense circuits, typically we're talking about something involving the amygdala. And when we're talking about reproductive and feeding and so forth, key areas involve hypothalamic circuits and on and on. So the survival circuits are what allows us to have these detection and response activities that are basically automatic. In the presence of an innate stimulus, like an innate threat like a snake, we freeze. In the presence of a learned threat like the side of a rock where we once saw a snake, we might freeze as well, but that's a higher level kind of association. And finally, simply the imagining of that rock might make us freeze as well, because it's also going to be able to activate those circuits. So survival circuits can be accessed in many different ways, but they are not what gives rise to our feelings. Our feelings are the cognitive interpretation that, for example, a survival circuit has been activated. Now, some people talk about basic emotions and non-basic emotions. I think that that's been a problem because it's made us think that there's two kinds of emotions with different circuits. But I don't think that the basic emotion circuits are emotion circuits. They are survival circuits. Now, why is fear so universal if not because of this innate circuit involving the amygdala and so forth? Well, what's universal is the ability to detect danger and the need to detect danger in every human, no matter what culture they live in. And the fact that every culture has to detect danger means that they will have a word for that and a set of cultural mores about danger. The words and the mores and the social, cultural aspects of it are what determine the experience, not the hardwired stuff that generates a response that is correlated with and that can amplify that experience.
Joseph, is there anything else you'd like to share before we close?
Well, we talked a lot about consciousness, and we humans tend to think of it as our prized possession. But I think it's also probably what gets us into a lot of trouble. It's the source of paranoia, of group identity and hatred, and we're moving ourselves towards, I know this is a kind of pessimistic view, that consciousness is allowing us to move ourselves towards the destruction of the planet. We can build amazing things, buildings, we can go to the moon, we can do all these things. And so we think that everything that we experience is good. And we always see it through our own little window. But only when our conscious minds are in sync across aspects of culture, aspects of the world, do we thrive and get along with each other and survive as a species. The more conflict we have, the more evil ways we come up with to seed hatred and separation, and the more anger we have at other people and other organisms, the more likely it is that we won't persist. Species come and go all the time. Who would have thought that the dinosaurs could have been eliminated? But they were wiped out by meteors or whatever it was that took them out.
They didn't wipe themselves out.
No, they didn't wipe themselves out. But what was interesting was what happened when they were eliminated. Tiny little mammals became the dominant species. And because they had a small body mass, they were able to survive the consequences. But dinosaurs didn't have the capability to destroy the environment and to wreak havoc on the natural biosystem in which we all live. But we do have that ability. Now, I don't think that we're going to destroy the Earth. There's been a lot written about, the Earth will survive, but we just ain't going to be there with it if we continue along these lines. So what's the solution? Well, I think consciousness is both the problem and the solution. It's our only way to get out of this is to get our conscious minds back on track, to understand each other and to try to get past all of the divisiveness and come together as a people.
Well, I agree with that. So do you have any advice for students?
Well, I got into this through the back door, more or less. These degrees in business administration and so forth, that my passion took me there. And students sometimes ask me, well, you think that would be possible today? And I'm not sure it is possible today because things have gotten so much more complicated. Students really need so much more background experience in molecular biology and genetics and physics and math and all of the things that are not things that I had at all or I had to cope with when I was coming along. So it's a different time. That doesn't mean students shouldn't strike out and follow their passions. That's always a great idea. But I don't think my model is necessarily the way to go. I would not try to discourage someone, say, coming from English or philosophy from going into neuroscience, because I think that there's a chance that you could pull it off. We started our neuroscience program at NYU, doctoral program, in 1989 or 90 or something like that. Our first group of graduate students did have an English major in them. So not so long ago, it was possible. And, it's not out of the question today. It's just a bit harder. The student would have to really bone up a lot. The usual story, I don't think this is novel. Everybody says follow your passion, but, you can't go wrong doing that.
Well, I have a question because this relates to emails that I regularly get on this because I get a lot of emails from students. And recently I've been getting emails from high school students about what to study in college. And I come at this with my own particular bias that I'm not convinced that they should necessarily start in neuroscience versus get a broader, science knowledge, maybe some engineering, other tools. What do you think when you're looking at people applying to your graduate program now? Do you think there's an advantage to having done an undergraduate degree versus your undergraduate degree in another area that's technical?
Yeah, good question. I think that, it's certainly not necessary. But, I would say that most students that are admitted have some kind of neuroscience background. But the field has become so broad that to include approaches in physics and math and computer science and artificial intelligence and philosophy and all of these things. So there is a place. It's a broad tent, and there's a place for a lot of different kinds of backgrounds in neuroscience. It's a little harder to come from the humanities, but I don't think it's out of the question, but I think it's more of a barrier.
Okay. That's great. That's a very practical answer. And like, I feel like when I'm being asked, and, I've been a physician for over 30 years and started out as an engineer, and what I know of neuroscience is mostly self-taught. So I'm not sure I'm necessarily the right person for them to ask. So that's why I like to get feedback from my guests. I have really enjoyed talking with you. I really enjoyed your book. It really gave me a different viewpoint. And I don't think I'm going to come down on the side of any one particular viewpoint. My goal is to expose my listeners to a lot of different perspectives on this question of consciousness. And when it comes to emotions, it's kind of hard to not include them. They're kind of an important part of at least the human conscious experience.
Absolutely. I think it's, that's really what we are thinking about all the time is
yeah.
what we're feeling.
Yeah, absolutely. So thanks again for taking the time to talk with me.
Well, thank you for having me, Ginger.
It was fun talking to Joseph Ledoux after reading his work for so many years. I highly recommend that you read his book, The Deep History of Ourselves, the 4 billion year story of how we got conscious brains, and then draw your own conclusions about his arguments. Today he mentioned that he has 2 radical ideas. One is that cognition evolved before emotions, and the other is that emotions did not evolve by natural selection. They just came along for the ride. These proposals are rooted in several other key ideas. He argues that behavior should be assumed to be non-conscious unless proven otherwise. This goes against our intuition, but it's actually solid from a scientific perspective, especially if you consider the growing evidence that much of what the human brain does is unconscious, including many tasks that were long assumed to require conscious awareness. I started to say conscious attention, but attention is actually one of those things that can happen outside of our awareness. Note that he was very clear that he's not denying the possibility that animals have conscious experience. He's just saying that we don't have any scientific proof that they do. In arguing that cognition preceded emotion, Ledoux uses the word emotion to refer to a conscious experience. In this context, there is no such thing as an unconscious emotion. Of course, he spoke as if cognition and emotion were entirely separate phenomena, which was not unreasonable in the context of our discussion. In the past, we talked with Louis Pessoa about his book, The Cognitive Emotional Brain, From Interactions to Integration, and we learned that the amygdala is actually involved in cognition. Based on what Ledoux said today, I think he would see this as entirely consistent with his view of the amygdala as being involved in survival circuits. Cognition just means choosing, whether it be a survival action or creating a perception based on incoming sensory data. One thing that we didn't have time to explore was the role of affect and its relationship to valence or value. In his book, Ledoux observed that value has been present from the beginning of life. Bacteria go toward some things and away from others. Many scientists see this as the basis of affect and emotions, while Ledoux uses the word emotion in a much narrower sense to refer only to our cognitively constructed experience. I think it's important to realize that this also emphasizes the hazard of trying to use a common term like emotion in a scientific context. Ledoux's position might seem extreme by some, but it does have the advantage of scientific rigor. Well, what about consciousness? The first point Ledoux emphasized was that much of what the brain does is unconscious, including aspects that have been labeled emotion. For example, he mentioned experiments where people were shown a picture of a snake for a very brief period, and it's masked so they can't experience it consciously, but they may still show a physiological response, such as an increase in heart rate. In his current language, he would call this a survival response rather than an emotional response. It's good to remember that physiological responses don't correlate well with subjective experience. This is a point that Lisa Feldman Barrett also made in her book, How Emotions Are Made. Both Ledoux and Barrett see emotions as something that are cognitively constructed. This approach has several critical implications. First, according to Ledoux, we can't know if animals are conscious. Also, if emotions are cognitively constructed, they could be unique to humans. Now, we didn't talk directly about the theories of consciousness during this interview because our focus was on Ledoux's position regarding emotions. But in the book, he lists 20 current theories, and he goes on to explain why he favors the category of theory known as higher order representations. In the show notes for today's episode, you'll find a link to the paper that Ledoux mentioned. It is freely available on the internet. You'll find that at brainsciencepodcast.com. Joseph Ledoux's new book, The Deep History of Ourselves, the 4 billion year story of how we got conscious brains, was released in late August 2019. It provides a comprehensive overview both of his work and the evolution of human consciousness. It's definitely a must-read for anyone drawn to the neuroscience of consciousness. Before I put Ledoux's work into the context of this series about consciousness, I want to repeat his key ideas. First, because even humans have a vast cognitive unconscious, we should not attribute consciousness to behavior based on its complexity. His default position is that any behavior is unconscious until proven otherwise. In Ledoux's view, we can't know whether animals are conscious because their behavior is not a reliable guide. His admittedly radical ideas are cognition evolved before emotions, and emotions are not the product of natural selection. Finally, like Lisa Feldman Barrett, who I talked to in episode 136, Ledoux sees emotions as cognitively constructed. This means they could be unique to humans. I want to emphasize two things that Ledoux did not say. He is not claiming that animals do not experience emotions, and he is not claiming that they are not conscious. What he is claiming is that we have no way to know. Finally, I want to emphasize that although Ledoux sees emotions as cognitively constructed, he agrees with Damasio's view that emotions are an integral component of conscious experience. Let's briefly consider how Ledoux's ideas compare with those we discussed in episode 160. And like I said, it's fine if you need to go back and listen to this episode later. First, even though Ledoux prefers the higher order theories to the global neuronal workspace theory favored by DeHaan, he makes extensive use of DeHaan's research about the robustness of unconscious cognition. One of the strengths of the deep history of ourselves is its comprehensive use of the latest neuroscience in the field. I also featured the work of Antonio Damasio in episode 160. As Ledoux noted, most of what they write is essentially the same. They take an evolutionary viewpoint, and they both regard emotion as an essential component of conscious experience. The difference is that Damasio thinks emotion appeared early in evolution, and Ledoux thinks it appeared late, perhaps only in humans. The fact that Ledoux and Damasio reach different conclusions based on the exact same data is very important. These diverse viewpoints demonstrate the fact that science is a very human activity. It's not a set of dry facts. As human beings, we always interpret the data through the lens of our particular worldview. Obviously, this can be dangerous if science is used to justify unjust behavior, such as racism or other forms of discrimination. There is nothing more personal than consciousness, so it's inevitable that people will have strong opinions about how to interpret the current data. What makes science different from many other human activities is that it strives to be a self-correcting process. For example, the limbic theory of consciousness was an elegant theory that fit the knowledge we had back in 1950. But it needs to be discarded because it has been essentially falsified by our current knowledge of brain anatomy and brain function. My goal in this series of episodes is to present an overview both of our current knowledge and some of the contemporary theories of consciousness. I mentioned that there are 20 theories listed in Ledoux's book. Obviously, I'm not going to attempt to cover them all, but you will come away with a good grasp of what the theories have in common and also where they diverge. Most of the theories seem to ignore the role of emotions. The fact that I consistently feature work by scientists who consider emotions to be an essential part of consciousness tells you all you need to know about where I stand on that issue. Next month, we will be talking to Dr. Michael Graziano about his new book, Consciousness Revisited. We'll be expanding on the ideas he introduced in his book, Consciousness and the Social Brain, which we talked about way back in episode 108. Graziano feels that the global neuronal workspace theory needs to be expanded to explain why the brain creates subjective experience. And he will tell us how his attention schema theory approach rises to that challenge. Meanwhile, if you missed it, don't forget to go back and listen to episode 160, which is the first part of this 4-part series on the neuroscience of consciousness. In the show notes for this episode, I have links to several other episodes related to this discussion. If you want access to all of this older content, please consider signing up for our premium subscription. It gives you access to the entire library of brain science along with episode transcripts. Please visit our website at brainsciencepodcast.com. And while you're there, please complete a brief audience survey. You can send me feedback at brainsciencepodcast@gmail.com, submit voicemail to speakpipe.com/DocArtemis, or post to the Brain Science Podcast Facebook fan page. And please don't forget to listen to my other podcasts, Books and Ideas and Graying Rainbows. Thanks again for listening. I look forward to talking with you again next month. Brain Science is copyright 2019 to Virginia Campbell, MD. You can copy this episode to share it with others, but for any other uses or derivatives, please contact me at brainsciencepodcast@gmail.com. The new theme music for the Brain Science Podcast is Mindfire by Tony Catraccia. You can find his work at syncopationnow.com.